Welcome to Study Loop.
For this problem, I'll note, first of all, that there are going to be two different approaches. One is going to be to simulate a data set using the given information, and the other way is going to be effectively equivalent to just doing the t calculations. So I'll hop over into RStudio and illustrate the two different approaches. One moment here. Okay, so actually what I'll do is first go through just the t approach. So the way that we would want to do this is first find the critical value. Then find the test statistic. Then output the conclusion. So using the sort of direct calculation approach, what I'll do is first set up, now you can see that up here I have created a R script. So what I'll do is within the R script, now this isn't the most generalizable way of doing this. Of course, if you want to get all of the cookies, then you might want to look into how you set up a script so that you can put in arguments, so that you can set all of these statistics at runtime. But I'm just going through this in a sort of straightforward way. So first we declare our values. So we have the mean values for group A, those are the soldiers, the sample size for group A and the standard deviation for group A. Then we do that for group B, the sailors. So we have mean B is 170.3, NB is 6, and SD underscore B is 8.5. Then we want to find the test statistic. So we have that our test statistic. Now I'll note here that because we have sample standard deviations that are very close to each other, we can assume that this is that the two samples are coming from populations with equal variances. So our t statistic here is going to be equal to mean value of A minus mean value of B divided by SD of A squared over n of A plus SD of B squared over n of B. All right, pardon me, I just realized, forgot to put in the square root there in the denominator. That is important. So there we find the t statistic. Then we'll find the critical value. To find the critical value, I'll call that t crit. We can use the qt command. We're not given a level of significance, so I'll say that I'm testing at the 0.05 level of significance. We have that the number of degrees of freedom is going to be the sample size for group A plus the sample size for group B minus 2. So with that, we'd find the critical value. Then we want to find our conclusion. So what I'll say is that we'll print our t-value, and then we'll have an if statement here for determining our outcome. So I'll say if the t statistic is less than t crit, then we print. One second here, I need to make sure I'm used to putting everything in, or to capitalizing the first letters, but I'm not. Yeah, it looks like that would mess things up in RStudio. All right, so we have print reject the null if t is less than t crit. Otherwise, or else, we print fail to reject. All right, so I've saved my script, called it ttest.r, and all I'll have to do now is put in ttest.r. Actually, one second here, I believe I might have to put in r script ttest.r. Or, okay, pardon me, I'm overcomplicating this. I'll just hit run up here and realize that I made another small mistake with my capitalization. Okay, run. So our conclusion using the sort of direct method is going to be that we fail to reject the null hypothesis, and we can see that is because our t-score is negative 0.7485, and our critical t-value is negative 1.7823, roughly. So because we are not in the critical region, we fail to reject the null hypothesis. The alternative method, as I said, is basic. It is something that's going to be a little bit more straightforward here. As I said, we can do this using basically simulated values. This is going to be a little bit less reliable, but one way that we can do this is to do t.test. X is a normal distribution. Now I'll note I can just put in NA and so on explicitly because I do have the data already sort of existing in my environment as it was calculated from running the script. So I'll do t.test x equals r norm n underscore a mean underscore a sd underscore a. Of course, if you're doing this directly without doing that sort of initial calculation step that I showed previously, you would want to be putting in the actual values here, but you don't need to create a separate script. You can just put them in the hard way here, so to speak. As I said, because we do have very similar sample standard deviations, we can safely assume that the variances are equal. So I'll put in var.equal equals false, and we have a one-sided alternative. So our alternative here is less. So we can see that our t statistic that we get out here is slightly different than what we found previously. Of course, that is because the data is being generated on the spot here, just based on the statistics that were given to us. But either way, we arrive at the same conclusion. We would fail to reject the null hypothesis because in this case, we can say that we would fail to reject the null hypothesis because the p-value is 0.3595. That is such a high p-value that this is not convincing evidence for the alternative.